All right, it is the last lesson for this unit on radicals. So what we are doing is solving equations involving exponential and radical expressions. So we're going to go back to solving some equations today. So go ahead and flip to page 13 for your last lesson. So what do we do if we run into equations that involve radical expressions or even exponential expressions? So let's think back. When we solved equations before, what did we do? Well, we used the inverse operation to undo operations that were happening to the variable. So whatever we wanted to solve for, we were trying to undo whatever was happening to the variable. So if it was getting multiplied by 2, we would divide by 2 because division is the inverse operation of multiplication. It undoes it. So what we know right now are that exponential and radical operations are inverses. So what that means is in order to undo a square root, well, the inverse of the square root is to square both sides or take it to the power of 2. If we want to get rid of a power of 3, well, the inverse of that is going to be the cube root. So that's how we are going to undo any exponents or radicals. So let's go ahead and explore our examples. So we've got this first one here. X squared equals 64. What are we going to do? Well, what are we doing? Let's go back to doing those boxes. We are doing our order of operations, PEMDAS, to X, and we are undoing those operations. So think about what is happening to the X right now. Well, we are taking it to the second power. Yes, we're squaring it. So how do you undo a square? Well, we take the square root. So what we need to do is take the square root of both sides. So let's take a look at that here. If I have x squared and 64, I want to take the square root of both sides in order to get that square to cancel so that the x is by itself. And then I need to figure out, well, what is the square root of 64? Now, the only tricky thing here is that, well, we know it's 8, but it could be positive 8. It could also be negative 8, because negative 8 times negative 8 is also 64. So whenever you do a square root, or basically any even-powered root, you're going to have to take the positive or the negative version of it. So just kind of don't forget that little plus or minus guy. It's not hugely important just yet, but it will be very important in the next unit. All right, number 2. We've got y to the third power equals negative 27. So we are doing our order of operations to the variable y. What's happening to y right now? We're doing y to the third power. How do we undo that? Well, we need to take the cube root. So what we're going to have to do over here is take the cube root of both sides. So take the cube root of both sides. The cube root cancels with the third power, and we're left with y equals, now this one, we're not going to have the plus or minus because the only way to get negative 27 is if we had a negative 3. So that's going to be it. All right, flip to the next page. Number 3, we've got the square root of x plus 4 equals 10. So this time we're back to x. Now again, think about your order of operations. So we have parentheses and then exponents, and the radicals are going to be the same level as the exponents. So that's going to happen first. So the first thing that's happening to the x is we're taking the square root. Okay, and how do we undo that? Well, what we're going to have to do is take it to the second power. So I'm going to draw that little caret guy to represent the exponent. So to the second power, just like what your calculator has, is that little like arrow thing. And then what else are we doing to x? Well, we're adding 4 to it, so we have to undo that with subtracting 4. So remember, we apply our operations this way, but then to solve, we go back upwards the other way. We go in the opposite order. So our first thing we have to do is subtract the 4, and then we're going to have to square both sides. So let's zoom in here. I need to subtract this 4 over first. That gets rid of that. And then I have the square root of x. 10 minus 4 is 6. Then, in order to get rid of the square root, I've got to take both sides to the second power. I have to square them. So what I am left with is x, and then 6 squared is 36. So I have x equals 36, and that's our answer. All right, next one. This one's getting a little bit longer here, but you can do it. Don't worry about it. So what are we doing to our variable? What's our variable this time? It looks like it's an n. Well, we have to do the parentheses first. So what's happening inside the parentheses? We are multiplying by 2. So to undo that, we're going to have to divide by 2. We're also subtracting a 1, so I'm going to have to add a 1 to both sides. And then we're taking it to the third power, so I'm going to have to undo that by taking the cube root. Okay? So remember, going down this way, but then coming back up this way to solve. So I need to take the cube root of both sides first. So I take the cube root, and that's going to get rid of this third power, so that I'm just now working with the 2n minus 1. And the cube root of 729, you should probably put that in your calculator. It should come out to be 9. All right, now I need to get rid of the 1 and the 2. So this is going back to what we did long ago, solving regular equations here. So I need to add the 1 over, and that's going to give me 2n. Those guys are gone. 9 plus 1 is 10. And then I need to divide by the 2 to get rid of that. And I finally am left with n equals 10 divided by 2 is 5. So n equals 5. All right, we've got 2 more examples here. They're a little bit tricky, and we're getting rid of the boxes, so you just need to kind of think about it yourself now. So let's look at number 5 more closely here. We have the square root of 2g plus 1 equals the square root of 4g minus 1. So before we handle anything inside the radicals, what we're going to have to do is get rid of them. So in order to get rid of the square root, I have to square both sides. Those cancel out with the roots, so then I just get 2g plus 1 and then 4g minus 1. Now I have to go back and solve. This one's got variables on both sides. Remember, we need to get the variables on the same side together. So either way, you could subtract the 2g or subtract the 4g. It doesn't really matter. I'm going to subtract the 2g. That gets rid of it on this side. I still have 1. 4g minus 2g is 2g. And I've still got this other minus 1 here. Now I'm going to have to get rid of this one. So I get rid of the subtract 1 by adding a 1 to both sides. That gives me 2 on the left, and I still have 2g. These guys are gone. Divided by 2, and then I finally have my final answer. 2 divided by 2 is 1. So 1 is equal to g. All right, last problem, number 6. Now this one, both of these are to the second power, so how do I undo the exponent of 2? Before I can touch anything in the parentheses, I've got to get rid of the exponent. Well, the inverse operation of squaring is the square root, so I got to take the square root of both sides. So what happens then is I have 9 minus x, and then 2x minus 12, and I have another situation where I've got variables on both sides, and I need to take care of that. So I need to get the variables on the same side. I'm going to go ahead and add this x over, get rid of it over here, leaves me with 9 equals 2x plus 1x is 3x minus 12. I've got to get rid of the minus 12, so I add the 12 to both sides. I get 21 equals 3x, and then I need to divide by the 3 to get rid of that. Also, this has gone up here if you like to cross things out. And 21 divided by 3 is 7, so I get 7 equals x. And you're done. All right, so your equations shouldn't be too much more difficult than that, so hopefully you do okay. If you need help, make sure you're asking for it. Good luck, and thanks for finishing this unit. Great job.